So for law of conservation of energy, this is important because you have to understand that the initial energy has to equal the final energy, and you would use this if you wanted to find the velocity of the train, let's say before it goes up the hill. So you need to understand that there's kinetic energy at the bottom and gravitational potential energy at the top, and those two have to equal each other, and vice versa if you were to try to find it at the bottom of the hill. Also, when it comes to centripetal motion, this is important when you're making, let's say, a camel hump, because you need to know that there's a certain acceleration to keep it over the top, and because there has to be that force that's pulling it into that circular motion. Also, Newton's third laws are important because this all comes into play when you talk about the number of g's, because you have to find that acceleration and divide by 9.8, and that's a limiting factor for safety reasons. And also you have to take into account power and the force that it needs to account for to pull something up. Kingda is safe because the limiting factor for safety is number of g's, and I calculated it to be between as 1.5, which is well in the max limit of 4 to 5 g's for a ride to be safe. And because there aren't any loops, there isn't a minimum. And for safety, for the thrill factor, that has to do with acceleration, because it doesn't really matter about velocity. It just has to do with how fast the ride is changing, and I found it to be around 15 meters per second squared, which is a high rate for something to be changing, so the ride would have a high thrill factor.